So for this question that we got over here is a patient or as an infusion of CSL 1 liter, which is infusing at a rate of 250 mils an hour. So every 1 hour, the patient receives 250 milliliters. The infusion has somehow stopped working, and what's left in the bag is 750 milliliters. And now we are required to use a gravity giving set with a drop factor of 20. And the question is asking us how many drops per minute we need to set the giving set so that we can infuse the remaining amount. So we can start breaking the question down, and we can say our remaining volume is 750, and that's what we'll be working with. Also, we know that the speed at which we're infusing this fluid before, or the rate at which we were infusing this CSL, was 250 milliliters per hour. And also we got a drop factor of 20. So what we could do with this question, or what we could do is we can just quickly freshen up and see the formulas that are normally used. So the formulas that we use to calculate rate in milliliters per hour is equal to volume over time. Also remember that when you're calculating your drops per minute, the DPM, we normally say volume divided by time, and this should be in minutes, and then you multiply by the drop factor to make sure that you get what you need as far as the drops per minute are concerned. So there is one way that we can use as a shortcut to get the answer for this question. What we could do is we could have the rate that we got over here, which is 250. Then this one needs to be converted. The hours that we got here needs to be converted into minutes. So we need to introduce the minutes here, which is 60 minutes in 1 hour. Then you multiply by the drop factor, which is 20. So at this point, if you had to use, your calculators and all that, you end up with your answer as 83.333 drops per minute. So we got our DPM as 83.33 drops per minute. Of course, here now we got drops. We can't use drops as a point. We can't use a decimal point for the drops as an answer because we are giving one drop, all drop, not into decimal points. So we need to round down this because it's less than a 5. So what we end up is 83 drops per minute as your final answer for this question. So if you are to look at this question again, there's a connection between the formulas here. That's why I use the shortcut, because here we go volume and time, and also we go volume and time here. This time is in minutes, this is in hours. On this side we got hours, because that's what's required. That's why I use the 60 minutes to convert these hours into minutes, which were used to calculate this rate of 250 mils an hour. Thank you. You can watch my second video on the longer explanation of how you can solve this question if you do not want to use the shortcut.